Good afternoon and welcome to the Database Administration Virtual Chapter Meeting. Today we're having a lecture on implementing and cracking the new security features in SQL Server 2016, and this is part one of a multi-part series. Ronan Arley will be presenting. My name's Julie Blomquist. I'm the moderator today, and we would like to thank our sponsor, Hewlett-Packard. They enable us to send out raffles for those who attend. For those who attend, there's a raffle drawing. Again, we want to thank the sponsor. We are one of many virtual chapters. You could go to your past login and associate with any of the other virtual chapters, and you'll get emails about the upcoming meetings. We do record these meetings, and they're posted on the website under the archive page. Here's some upcoming SQL Saturdays. SQL Saturdays are a one-day conference, and they're held all around the world, and they're usually free, or there's a nominal fee which would cover your lunch. Visit theSQLSaturday.com. You can also join a local chapter. That's for, a physical chapter if there's one in your area, and you could find that information from the past websites. There's many opportunities to volunteer with PASS. You can get to that from the PASS website, and there is also an Outstanding Volunteer of the Month award that you can nominate people for. Our recordings are put on YouTube, so please visit the SQLPass.org and become a member, and you'll be able to see the YouTube videos. And here are the LinkedIn, Facebook, Twitter, the PASS membership. And don't forget, it's a free membership. Again today, Ronan Arley, he's a senior consultant and an application data architect. He's more than 15 years experience in a variety of programming language and technologies, leading development teams and software companies, SQL and BI enterprise level solution. Ronan is active in communities. He's also known as, I think it's Patuach, or he'll correct the saying, in the field of programming, SQL Server, and T-SQL. He serves as a moderator at MSDN, an administrator at several of the Microsoft blogs, and as one of the Microsoft TechNet Wiki community leaders. Ronan writes technical blogs, TechNet articles, and blogs, and he is a data platform MVP. And Ronan, I'm passing the presentation over to you.
Okay. Let's see. Can you see the white screen?
Yes, I can see the slideshow.
Great. Okay, so thanks, Julia. I'm honored to be here. Good day, everyone, and welcome to part one in security features meeting. My name is Ronen Arieli. I own a small business in Israel. We provide consulting services, supporting, and project management around the world. You can find me online in various communities using the nickname Pituach. Okay, but I'm pretty sure that you did not come to hear about me, but to see the lecture. For more information, you can download the presentation file or simply Google my name in any search engine. The demos code and the presentation file will be available online. I recommend you to follow my Facebook page where I will post more information. What are we going to talk about today? SQL Server 2016 provides several new data security features. The lecture will be held in two parts. Today, in part one, we will explore the new feature, dynamic data masking. The second part will be presented on Wednesday, February 8th It's 2 weeks from now. What is dynamic data masking? I assume that everyone familiar with the next scenario. We contact the call center support and they ask us what is our name. Using this information, they find our account and now they ask for the last 4 digits of our credit card. It's important to understand that the supporter cannot see the entire number. The credit card is dynamically masked. Dynamic data masking is the process of hiding original data, can be partially or fully, at real time by displaying different data. For example, in my illustration, the number of the credit card is partially masked. The most common procedure is to manage the masking on the client side. This can be done in different levels, while masking the data in lower level can increase the security significantly. But we still exposed to external attacks. SQL Server 2016 new feature allows us to mask the data in a tables column level inside the database. Let's move to the demo and show how it is done in practice. Julia, can you see my screen, my SSMS?
Yes, you're fine.
Great. For the sake of the demo, I will create a new database so we can start from scratch. Since we want to demonstrate security based on user permission, let's create a new user. What I will do, I will create a credential and then a login based on the credential and a user in the database. Okay, first I will create a table. Let's create a new table which include a variety of type of columns. And I will insert 2 rows. Okay, now we can learn how simple it is to implement dynamic data masking. But before I continue, allow me to be lazy. I will use a short name, DDM, instead of saying dynamic data masking each time for the rest of the lecture. So DDM in SQL Server 2016 is simply a rule that is defined on the columns level. We can implement DDM on existing column by altering the column and adding the property masked, as I will show you in a second, like this. Masking the data can be done using several built-in functions. The first function that I will use named partial. The partial function gets 3 parameters as input. The first parameter defined the number of characters that will be exposed from the original data from the left side. The second parameter is a constant. It will be added to our result. And the third parameter defines the number of characters that will be exposed from the right side. This perfectly fit for credit card masking, and you see I will implement these properties on the credit card column. So if we have this input, this will be the original value. We expose 0 character from the left. Then we show this template, which will be represented like this in the result, and we expose the 4 last digits. This will be the mask data that returned. Okay, the second function. The second function, which I will use, named email. And you can guess that it's basically meant to use for masking emails, and I will use it for the email column. The function return text formatted as email. It looks like a legal email address. I will show it in a second how it behaves. The third function that I want to use, named random. One second. Let's confirm that I execute this. Okay. The random function is perfectly work on numeric values. It gets two parameters as input, minimum and maximum, and each time that we execute a select, for example, the function returns a random number between those two values. We will use it to mask our social security number. The fourth and last function that we will use, named default. It is probably the most interesting function as it behaves differently according to the mask data type. I will use this function to mask several columns. I will use it for the password, for the salary, and for the birthday. And I will show how it behaves in a second. I want to execute a simple select query and examine the result. Sysadmin by default can see the exposed data, but any other user which did not get permission to see unmasked data will be able to see only the masked data. In order to demonstrate the masking, I will use the new user that we have just created. I will give the user minimum permissions on the table to work with the data, which means let's give him select, insert, update, and delete. And now I can execute a simple select. First query, I will use my personal user, which means sysadmin, and the second time I will impersonate to the new user. Let's go over the result very fast and understand what we got. Okay, we can see that the first three columns are not masked. SSN, the social security number, we mask with the function that fit for numeric, random. We can see that each time that I execute, the number will be different. The credit card, we masked using the function partial, and we exposed only the 4 last digits. Email, I didn't mention it yet. Email return the first character from the original value. It exposed this character, and it complete the text to look and feel like a real email. And the last 3 columns, password, salary, and birthday, were masked using the default function. Password is a text. Default on text return series of X's. Default, the same function that we use for numeric, will return the value 0. And default on date time, date, etc. will return this date. Well, this is all the basics. In less than a second, with almost no code, we successfully build a masking system. If the user does not have the right permissions, then any query hides our real values and return only the masked data. It is important to understand that although our data is masked, the user can still manipulate the data using DML queries like insert, delete, and update. In fact, the user can even use simple filter using the where condition in order to manipulate specific rows. I will go back to this point in a short time once I will talk about cracking the masking. Let's demonstrate simple insert, update, delete. I will impersonate to the user, the new user we have just created. And everything that I will execute now will be done as the new user. So simple. Insert will look like this. We added this row. Let's update this specific row. Notice that we filter the data using the real exposed value. The user cannot see the exposed value, but in the filter, we use the real value in order to filter our data. Let's delete the new row. Again, we are using filter with the real exposed value. And you know I like to be sysadmin, so let's go back to become sysadmin. I think that it's a great time to mention that by granting the user the permission named unmasked, the user will be able to see the original data. By default, any new user will only see the masked data. Here is the way that we can grant or revoke the permission. Julia, how many people do we have in the meeting right now?
I'm showing 212, and the only question I had is the masking of the data, does that only work with the SQL Server 2016?
That's great. Okay, you can find everything that I did until now well documented. I want to take a short break before we move to the next section where I will raise the level. This is a great time for questions. Let me check if there are. Julia, I cannot follow the chat. Do we have any questions?
No, the only question was, is this only 2016?
Okay.
The masking, and then
yes, this is a new feature, as the name of the lecture said. This is a new feature on SQL Server 2016. Moreover, until the edition SP1, it used to work only on Enterprise and Standard Edition, but right now, once SP1 insert, we can use it on any edition that we want. Even Express, the free edition, can use this feature.
Will this work with row level security?
The next meeting will be about row level security and cracking it as well. And yes, this work together. It is no problem between different security features. It's different manganon, but we need to know the limitation because there might be some strange behaviors. I will show today some of those. So the short answer is yes, it should work.
And does this work with the in-memory OLTP databases?
I'm sorry, I don't have the answer for this. I need to check. I didn't try to use it on in-memory table, and I don't find the reason to do it because this feature costs performance. It needs resources. It's pretty good and it's working well, but usually in memory table I will use something like very heavy OLTP operation that I need. So I don't have the answer right now, and I don't think that personally I will use it only in memory table.
And does the unmask permission apply to all mask columns, or can the permissions be exclusive to a specific mask column?
The mask is a property of a column. It's not related to permission. The permission, it's like any grant permission that we give. We can give it on the table, and the user will have all the options for the table, not for specific column if we gave it to the table. Okay, there was nothing unique about granting the new permission, but the mask itself can be done on a column level. It is a column properties. Let's continue. I will have some more breaks for question according to the time. But we want to take the lecture for the next level. For the sake of the next section, I will impersonate to the mask user again, and from this point forward, all my demo will be done as the mask user. So first of all, let's check who we are. Okay. My first goal, now we are going to check how we can crack the masking and expose the data. My first goal is to expose the user social security number, the SSN. This is the simplest case since SSN is simple integer. At this time, we get a random value each execution, but we saw that we can filter the data using the original real value. My procedure to expose the data based on this fact. Let me add a simple filter here. And you can see that if I add a filter using a wrong SSN value, then the query does not return anything as expected. Theoretically, I can simply create a loop on all possible values. I can try with 1, then go 2, then go 3, and so on. Once I will get the real value, the query will return the data. For example, in this case, once my loop reached the number 1, 2, 3, 4 till 9, which is the real value, then the query return the row. The query return masked data, but we know exactly which is the real value now because we used it in the filter. Of course, looping is not a great idea. Basically, all we need to do now is to find a better solution that fit the way tabular database work. A solution that's based on set instead of loop. One simple solution, for example, is to use virtual numbers table. I will show you a simple example. I'm using CTE, which creates a numbers table, and now I can use this numbers table in order to expose the data. Moreover, I can now filter, remove the filter if I want, and get the information of the social security number for all the users in one execution. Okay, I found out that in some cases we get better performance if we split the SSN into two small groups. This way I find first 5 characters as a first action and then the 4 last character separately. You can see it here. Let's move to the second goal. Now I want to expose the user credit card. Since credit card number basically include 4 integers, it's not much more complex to expose the credit card than finding the SSN. For example, I can remove all the dashes from the text, so we will get one long number. Another option is to find each part of the credit card number separately. And this is the way that I will use right now. So this is my simple query. You can see that I'm working on each part of the credit card separately. And we need to wait a bit. It's not immediately return the result. Exposing date time or date is basically the same as exposing numbers. Instead of using numbers table, we can use the calendar table. So allow me to skip this demo. The logic is exactly the same. But I do want to take this procedure to the next level. You might notice that our solution does not work in 0 time. Creating and using virtual numbers table on the fly and basically using table without index can reduce performance. Wouldn't it be better if we had a numbers table in the database which is already indexed? We don't have time to discuss all the security breaches, but I do want to show a simple option that can improve our goal. Did you know?
Ronan,
Yeah.
can you just scroll up and show the entire query? We've had requests for that.
Yes. I will give all the code for download, so it's better to focus on the content and check the code after. But basically, again, I'm using CTE here in order to create a number table, and then I expose the data in 4 parts. Okay? It's a simple join in order to find the right value. But now I want to take it to the next level and to make it execute faster. As I started to say, it will be great if we had a numbers table which is indexed in the database. Did you know that any user can work with temporary tables? Tables that are stored in the TempDB database in spite of the fact that the user does not have any permission on TempDB database. I remind you, I am now execute everything as the mask user. I don't have any permission, and let's create a numbers table. And I indexed the table at the end. Great. Now that we have indexed number table, we can improve our solution. We can expose millions of rows in several seconds. And this is the new query. Okay, temporary tables can help improve our actions, but they do not give us new information. Cracking basically based on information. If we have more information about the database structure, for example, then we might find a better algorithm to do whatever we want to do. In this demo, I showed you how I created the table. Therefore, you all know what is the table structure. But in real life, this information should not be exposed to the client. For example, I'm sure that it is clear to everyone here, as everyone here are DBAs, it's clear that the client should not get information about which function we used in order to mask the data. No one will design a system that gives this information. It makes no sense. Or maybe someone will. Voila. I have no permission and check. It's amazing. It's amazing how much information I can get without any permission. And by the way, I'm not talking about positive amazing. Let's see what we can see here. With a simple query, I got all the information about which columns are masked. And I get exactly the information which function the DBA used in order to mask the data. And together with the information about what is the data type, and I even have the length, I can do magics. You can see even in the partial that I exposed the 4 last digits. So now I know that those are real numbers. What is the time? Okay. Usually when I give this lecture, at this point or probably 10 minutes ago, people start to ask me if the new feature is useless and if it does not give us any security. It is a bit hard to get a response in a webinar where I cannot see your faces. I'm talking to my laptop, hoping that there is someone there. I do hope that you enjoyed the meeting so far, and I assume that someone already started to think about this point. So I invite you to wait to my conclusions, where I will give some personal point of view, several useful tips, and a closure. Don't get too hasty to think that the feature is not useful. It is. Since we have time, okay, we have time to show an even more complex case. What about finding values of free text? For example, how can I find the password? I will base my solution on 3 steps. First, I will find the length of the password. This information can help us to narrow the search and reduce the number of loops we need to do. Most important, it costs nothing. Simple query, and I can find the exact length. Okay, I know that user ID 1 has a password length 5. Second step will be find all the characters that we have in the password. At this step, I don't care about the order of the characters, and I don't care how many times each one of the characters take part in the password. I just want to find which character are used. Let me copy the script. And all the information I will insert to a temporary table in order to use for the final step. You can notice here that I'm only looking for characters in the English language. All you need to do if your password can be in other language is to change this part in the query and add the ranges of the character according to your language. Or you can simply select search for all available characters. Okay, I execute the query and I know now that those are the only characters that we have in the password. You can see that I got 4, which means that one of them is duplicate in the password because we saw the length is 5. Let's move to the third step, which is the final step. I will use the information from previous steps. We will use a simple loop 5 times, which is the password length. And I will find which one of the characters from step 2 fit to each place. Very simple query. Voila. This is the real password. Okay. Let me show you some more interesting stuff, which I skipped because I wasn't sure if we will have time. First of all, how we implement masking while creating the table. It's very simple. You just add the properties mask for the column like this. And a very strange behavior that I will show you. This is fit for a riddle, but I cannot ask you to put your hand up, so I'll just show you. Check this query. It's a very simple query. First I will ask to get the password, which is mask, we all know. And this use the default for text, so it will return 4x's. Then I want to get the length of the password, which would be 4, because we have 4x's, and the data length, and even I will try to do a simple math operation, the length plus 1. I will give you 5 seconds to think for yourself. I cannot, it's not an open lecture with the audience, I cannot see you, but think for yourself, what do you think that this query will return for each column, except that the first one, which we know, it will be 4x's. 5, 4, 3, 2, 1, let's see the result. The password returns the value, which is 4x's, but the length is 0, and the length plus 1 is 0. This is inconsistent information which can lead to crashing your client-side application. You must be familiar with this behavior. You need to be careful. The way Microsoft implementing masking is very dangerous for the application side. Think about the case that your application get the password for access and then it use the length 0. It makes no sense. The reason it's behave like this is that the masking is done on the value that we return, and the length is a numeric value. The masking by default using the default function, and the default function on numeric return 0. So this returns 0, the data length returns 0, and even the calculation of the length plus 1 return 0. Getting the password in one query. I have a totally different logic. We can do whatever we think that can bring better performance. Just to show another way. In the previous demonstration of exposing the password, I used 3 steps. This is one query, 1 step that I can get the information using for XML, and this is the password. We can get much better solution if we have a table that include all the characters instead of using numbers table. In this query, I'm using two functions, the ASCII function and the char function, in order to convert between the characters and the numbers. Okay, there is a very important point that I want to mention regarding partial function. I want to remind you, this is how we use partial function. If the length of the original value is less or equal to the sum of the first parameter and the last parameter, in this case less or equal to 5, then the function returns the constant part, only this part. And if the original value is null, then the function returns null. Those 2 points are totally opposite to the basic idea of DDM, which is to be transparent to the application. This is very bad implementation in my personal opinion. I prefer, for example, to get the duplicate characters if the original data is too short, and keep the final format as we expect. This is extremely important for the application that expect to get specific format from the server. The current implementation exposes the fact that we have a value that is less than the format length, or worse, it exposes when we have null in the database. Okay, so you need to remember those points if you are using the new feature. Any question? We can stop for a short while.
Ronan, is this supported in Azure SQL?
Yes, it is. And it's supported in Linux as well, for the next question.
And then,
it works on Linux very perfectly. In fact, my first idea was to do all this presentation on Linux, but my MSDN account was only renewed today, so I didn't have time to prepare the virtual machine. But it worked perfectly on Linux as well.
so then when people, if they are doing a bulk extract and BCP work, does it work the same way? Will it get mass data?
Sorry, from the beginning, I lost you.
If they're doing a BCP or a bulk extract, will the data get masked if the user performing the BCP has no unmasked permissions?
If we are doing insert, we need to insert the exposed data, the real values. When we are exporting the data, it will be masked.
Great. And that's it for now.
Okay. I do want to mention a very useful option to implement dynamic data masking without using the new feature. This means you can use it, this procedure in older versions, and you can still use it in the new version as well if you don't like the built-in limitations and behaviors. But most important to remember that in order to use it, you need a lot of developing time. I don't have time to go over the next idea in depth, but I will show you a short demo. The basic idea is to create a security layer in the database using elements like functions and stored procedures. And instead of giving the user the permission on the original tables, we give him permission only to work with our elements, the security layer. You can find more information in one of my blogs. You can Google for it. Let's see a very fast demo, how it is done. Let me find it. Here. You have the link to the original blogs here, and you can download the code, so you can check the original blog as well. Okay, I'm creating table and insert two rows exactly like before. The only difference is the name of the table, so I will not need to remove the previous table. And now I start to create the security layer, which basically means I will create view, and you can see in my view that I implement the masking as part of the select query. This option is much more flexible than the built-in feature, since we can use any masking that we want, any format that we want. For the sake of the lecture, I chose to get result exactly like the new feature in SQL Server 2016. Same procedure, I create function that mask the data, and I need a trigger in order to work with the view. Okay, and grant permission. I grant permission to work with the view, not with the table, and with the function. Execute. Now we can examine the way that we work in older versions, and if you want in this version. As a sysadmin, of course, I get all the data exposed. But if I will try to use impersonate, let's confirm, okay, I will get the data mask. I can even insert data, delete, do everything behind the skin. This will be using the trigger that I have just created, and go back to be sysadmin. Okay, let's go back to our PowerPoint presentation for a short discussion and closure. Dynamic data masking is a very powerful feature which gives us a lot, but like anything, you need to know what are the limitations. TDM does not bring us security in the user level, which means any user which have a select permission can expose the data. Moreover, if the application does not secure against SQL injection, then the user can expose the data. It is not flexible since we are limited by the built-in function, the masking function. With that being said, it does bring security to the server side, which eliminate attacks like man in the middle. It is totally transparent to the application. Well, okay, maybe not totally, but it is basically transparent to the application, and it can prevent accidental exposure of data. Of course, what we have done here today, it's not something that can be done accidentally, so it's a great feature to prevent accidental exposure. It can save development time significantly. And this is the main advantage in my personal opinion. We are talking about days of developing if we really want to develop a masking system in compared to several seconds. And it is relatively bring us good performance. In short, it can be used behind the application where the user cannot execute free queries. I recommend to read a blog that I wrote about this topic in the past. At the end of the blog, the link that you see here, I published a direct response from the Microsoft Data Security team. We are in contact for a long time, and they sent me their point of view regarding what I'm showing you here today in order to publish in public. So I recommend to read it. I must clarify that my goal was to show that the data can be exposed and not to show you how to do it. In production, we can use better algorithms in order to expose the data. In fact, I have several scripts that I wrote, but for the sake of the lecture, I focused in simple examples which can be explained in easy way and can be demonstrated fast. I showed you an example of implementing DDM without the new feature, which you can implement in older versions as well. And in our next meeting, we will move to discuss two other security features, row-level security and always encrypted. I hope that you enjoyed the meeting and that I will see you in part 2 of security features in SQL Server 2016. Once the registration will be opened, I will post the information in my Facebook page. In addition, the members of the DBA Pass chapter will probably get an email. You can download the entire demo code from this link. And thank you. Thank you all for coming to the meeting. It was fun to be here. I will stay online for a while. If there are any more questions or discussion that you want to talk about, please feel free to ask. If I will find a way to copy the entire chat, I didn't find it yet, then I will go over and check later on if there are any questions that need to be answered. I will post all the answers to questions that we skipped later on. So thank you again.
Ronan, do you have any information on performance with large data sets?
Yes, it costs performance, but it's I don't have the numbers now because I didn't prepare it, but I did check the issue. In general, I got that the performance are better than other solutions that we implement in the database level. Of course, it's less performance than implement the security in the application side, but it's more secure. So it's pretty good solution, but it costs performance.
That's it for all the new questions. I do have access to the question log and I will be sending that to you. Again, thank you very much for the presentation. A lot of the comments were, it was very well put together and simple to understand. This session is being recorded and will be posted to the archive page of the DBA virtual chapter. I also have the slide deck, which I'll be posting, and I've requested the scripts to post as well. Whoops, one more question.
Yes.
This presentation's been very useful. DDM, while useful in some controlled application situations, probably won't work for them as a general solution. The point about exposures for someone with direct query access directly addresses his concern. It's a particular issue in dev and test environments, and they said thank you for the presentation. It was both useful and great. So I'll be sending all the questions and comments over to you, but most everybody has been extremely positive. So if you can...
if you have time, I can stay a minute or two or a bit more if someone wants to discuss the topic more. For example, we have 2 minutes, so I will say something.
Yeah,
yes.
I don't see any more. Are there any more questions?
Okay.
Okay.
So thank you all. Bye-bye.
Thanks again. Bye.